Hi, this time let us solve the given equations and solve for the general solutions by the use of the aberration of parameters. And you have here a given equation which is d raised to the second derivative plus y multiplied by your y equals to cosecant x cotangent x. And the first step we need to consider is to write the auxiliary equations. And you substitute the value of your d by your m. So m sub 2 m squared plus y, and you need to equate it into a 0 because your f of x here is cosecant x and cot x, and it is constant. So therefore, the constant is equals to 0, and your dependent variable here is y. And by your equations, you can solve the value of your roots. So upon simplifying it, you can solve for your roots, which is m equals to positive I and your negative I, which is your m sub 2. And then you can write your characteristic equations. So your characteristic equation formula will be y sub c equals to c1 e raised to positive ix plus c2 e raised to negative ix, because you have your positive and negative value of your roots. And then, by simplifying it, you can multiply your c sub 1 by your cos x plus I sin x, and your c sub 2 by cos x plus I sin negative x. And now, upon simplifying it, you can obtain the value of your c sub 1 cos x plus c sub 1 I sin x plus c sub 2 cos x minus c sub 2 I sin x. So, let us say that combining like terms will be c sub 1 plus c sub 2 multiplied by your cos x, because there is a like terms in your given equations. And then your c sub 1 here will your sin x here will be multiplied by your c sub 1 I plus c sub 2 I. And then let us say that your c sub 1 plus c sub 2 is equivalent into c sub 1, and your c sub 1 I plus c sub 2 I will be equivalent into c2, and your y sub 1 here will be cos x, and your y sub 2 here will be sin x. And therefore, you have your characteristic equation of your multiply your c sub 1 by your y sub 1. So c sub 1 times cos x plus c sub 2 times sin x. So you have now your yc. So, and then now let's move on into the to get the Wronskian value. So by the use of the Wronskian method, so solve for your Wronskian. So your Wronskian here will be your y sub 1 and your y sub 2, which is cos x and your sin x. So the Wronskian, the determinant of the Wronskian will be your formula, which is y sub 1, which is the first row, and your y sub 2. And the second row will be the derivative of your first row. So upon substituting it, so your y sub 1 here will be cos x, and your y sub 2 here will be sin x, and the second row will be the derivative of your first row. So it will become negative sin x and cos x. So by simplifying it, you need to cross multiply, which is cos x multiplied by the cos x, and subtract by the product of your negative sin x and sin x. So by simplifying it, you can obtain the cos squared x plus sine squared x. So it is equivalent into 1. And then you can solve for your Wronskian 1. Upon looking for your solving for your Wronskian 1, you can solve by the determinants formula, which is 0 over f of x, and then you can copy the previous determinants of your Wronskian, which is y sub 2 over y sub 2 prime. And then you substitute the formula. So you substitute the 0, and your f of x here from your given equation will be your cosecant x and cotangent x. And then your y sub 2 here will be sin x, and your y sub 2 prime, which is the derivative of your y sub 2, will be cos x. And then you simplify, and then you multiply the 0 by your cos x and subtract it by the product of your cosecant x, cot x, and sin x. So upon simplifying it, you get the negative cosecant x, cotangent x multiplied by your sin x, and then you simplify the negative cosecant x by trigonometric function, which is negative 1 over sin x, and then your cot x will be cos x over sin x, then multiply by your sin x. And then to get the answers, you simplify the given equations, and you can get negative cos x over sin x. That was the value of your Wronskian 1. And then solve for the Wronskian 2. Your determinants here will be you copy the first column of your Wronskian y sub 1 over the y sub 1 and the derivative of your 1 sub 1, and then you copy the second column of your the Wronskian 1, diba? You copy the column of the Wronskian 1, so it is 0 over f of x. Okay, and then upon substituting it, you have your y sub 1 cos x, and the derivative of it is negative sine x, and you substitute the value of your 0, so it is equivalent to 0, and your f of x here will be cosecant x and cotangent x. So upon simplifying it by cross multiplication, cos 0 times negative sine x, then so you subtract it by the product of your cos x and cosecant x cot x. So therefore you get the value of negative cosecant x cot x multiplied by cos x. And then upon simplifying it by trigonometric functions, you get your cosecant x will be 1 over sine x multiplied by your cosecant x, which over sine x, which is the value of your cotangent x, then multiplied by negative cos x. So upon simplifying it, you get cos squared x and over sine squared x. You have now your Wronskian 1 and Wronskian 2. And that is necessary later for the substitutions of your formula. And now, you can solve for your u sub 1 prime and u sub 2 prime. Upon solving your u sub 1 prime and u sub 2 prime, you have now your formula to get the value. So, in solving u sub 1 prime, so your formula will be Wronskian 1 over Wronskian. So, upon substituting it, so you have your Wronskian 1 negative cos x over sine x over 1, which is the value of your Wronskian, equals, so it equivalent into the negative cos x over sine x. And yung u sub 2 prime mo, so it is equivalent into the Wronskian 2 over the Wronskian. So upon substituting it, you can have your value, which is negative cos squared x over sine squared x. And now you have now your value of your u sub 1 prime and u sub 2 prime. And now you can integrate the value of each of the following. So you can integrate the value of your u sub 1 prime. So upon substituting it, let us say that let u will be your sine x and the derivative of u will be cos x dx. So upon substituting it, you can have your negative du over u. So by the loss of the integrations, so it is equivalent into the negative ln u, which is you substitute the value of your u, which is negative ln, then times sine x. So you can have now your first integrations, and the second integrations you need to consider is your u sub 2 prime. So upon substituting the u sub 2 by the loss of the integrations formula, so you can have your negative cosecant squared x dx minus 1 dx. So it is from your given equations, and you can obtain the value of your integration, which is negative cot x minus x. And you can substitute it to your characteristic equations. So from your previous characteristic equations, to solve for the value of your particular solution is yp equals to u sub 1 prime cos x plus u sub 2 prime sin x. So you substitute it the value of your u sub 1 prime. So your u sub 1 prime will be negative ln times sin x, and you multiply it by your characteristic equations, which is your cos x, then plus the value of your u sub 2 prime, which is negative cot x minus x, then multiply is by sin x. And then you substitute you simplify it. So upon multiplying each of the term, and you can get the value of negative cos x ln sin x minus cos x minus x sin x. So that was the value of your yp, and you already get the value of your yc and the value of your yp. So therefore, you can solve for your general solution, which is y. The formula will be y equals to yc plus yp to obtain your final answer. And now y. So let us substitute the value of your yc from your previous answers. So you have your c sub 1 cos x plus c sub 2 sin x, then you add the value of your yp. So here, the value of your yp, negative cos x ln sin x minus cos x minus x multiplied by your sin x. So you combine all the like terms. So what is the like terms here? So you notice that there is a negative cos x and the c1 cos x. So by combining like terms, so therefore, by the cumulative property, so c1 minus 1 multiplied by your cos x plus c sub 2 sin x plus negative cos x ln sin x minus x multiplied by sin x. And you notice that there is a c1 minus 1 because of c. By the laws of integrations, so the c1 minus 1 will be equal to 1. So equal to c rather. So it is equal to c. So therefore, your final answer here will be y equals to c sub 1 multiply by your cos x plus c sub 2 multiply by your sin x minus x multiply by your sin x minus cos x ln sin x. So this is your general solution or your final answers from your given equations, which is d raised to second derivative plus 1 multiplied by y equals to cosecant x cotangent x by the use of the variation of parameters. So thank you.